Hello, this video about absolute value is considering another way to define absolute value. So in class, we discovered that f of x equal to absolute value of x, that the parent function, absolute value of x, is equivalent to the function f of x equals the square root of x squared. So that's a big idea. We saw that those graphs produce the same graph. That means the inputs, every x input had the same output f of x for both of those functions. So we have this big idea that we can now define the absolute value of x to be the square root of x squared. Or that you can say that the square root of x squared is equivalent to the absolute value of x. So we're going to use this fact to simplify. This is going to be something that we come back to later in the term, but we're going to get our first exposure since we're talking about absolute value functions here. So using this fact that the square root of x squared is the same as the absolute value of x, I know that I can say the square root of 25x squared would be the square root of 25 times the square root of x squared, which is simply 5. And here we have square root of x squared. We know that is the same as the absolute value of x. So square root of 25x squared is equivalent to 5 times the absolute value of x. In the second example, we have the square root of quantity x minus 4 squared. Well, instead of having square root of x squared, we have something else squared. And that something else can follow the same pattern. We can say the square root of that x minus 4 squared is the same as the absolute value of x minus 4. Looking down here, we have the square root of x squared plus 10x plus 25. Now we'll talk more about this. We cannot separate this into 3 different square roots added together. So right now you'll just have to trust me on that. We'll discover some more about that later in the term. But I do know that this trinomial on the inside feels familiar. What is this the same as? That is the same as x plus 5 squared. Now we can go out to the side and kind of check. X plus 5 squared, what is that? Well, that's the same as x plus 5 times x plus 5. And if I use the distributive property and I say, okay, x times x, x squared, x times 5, 5x, plus 5x, plus 25, I do get x squared plus 10x plus 25. So x squared plus 10x plus 25 is the same as x plus 5 squared. Now coming back to our problem, using this above fact, the square root of x squared is just the same as the absolute value of x. So here I have something squared underneath the square root. I can simplify that by just taking that is equivalent to the absolute value of x plus 5. So one more that I'd like to talk about that I didn't type up for you. Let's talk about the square root of x to the 4th. Okay, we don't have a separate fact for the square root of x to the 4th. We have a fact that says the square root of something squared, right? Square root of something squared is equal to the absolute value of whatever that is. So how can I rewrite what's underneath this radical as something squared? Is x to the 4th the same as something x to the something squared? So again, I'm asking myself, I want to rewrite this as a quantity squared. What would have to be inside here? X would have to be in there. X squared is not x to the fourth, but x squared squared is x to the fourth. So my fact says that the square root of x squared, or the square root of some number squared, is the absolute value of that number. Well, in this case, this is the absolute value of x squared. So let me ask, we have one more step. Can x squared ever be negative? Can you square a number and end up with a negative number? If you square a negative, let's say you square -5, that's going to be positive 25. Okay? The absolute value of x squared is never negative, so those absolute value bars are redundant. We don't need them. That's just the same as x squared. Now, why do we have the absolute value bars on just the x up here? Well, any number x could be negative. So when we take the square root of that quantity squared, we're looking at the positive amount right there. So we don't need that here because x squared will always be positive. Okay. Before moving on to the next video, try this. And again, this is kind of an introduction to this idea of linking absolute value and the square root of x squared. So we'll see it more, but let's give you a few to try. So again, the directions are to simplify using those facts. So the first one, simplify the square root of 49x squared. Simplify the square root of x plus 3 squared. And the last one, the square root of x squared minus 2x plus 1. Okay, give those a try, bring those to class, and try those before moving on to the next video. Thanks.